Hello everyone, welcome to engineering study, and today we are going to cover the remaining part of index properties of soil, and the topic is specific gravity and relative density and relative compactness of soil. In my first three lectures, I have covered almost 7 index properties of soil, and today we are going to cover the remaining part. And who have not who have not watched my first three lectures, first watch the first three lectures very carefully and then come to my lecture 4. And what is today's topic? Today's topic is specific gravity. Now, what is specific gravity? Actually, this term we have read about this term in our school level. Relative density. And what is this? Relative density means a density with respect to a density of a material with respect to some standard fluid. A density of a material with respect to some standard fluid. Okay, this relative density in our soil mechanics it is called as specific gravity. Density of a material with respect to some standard fluid. In soil mechanics, we assume that the standard fluid is water. Okay, so what is specific gravity? Actually, specific gravity two types: true specific gravity and mass specific gravity. In true specific gravity, it is defined as the ratio of the weight of soil solid of particular volume to the weight of same volume of standard fluid. And in our case, the standard fluid is water. So what is true specific gravity? Density of material by density of water. Density of material, what this is soil solid. So density of solid by density of water into G by G, so equals to gamma S by gamma W. And how this came, I have covered this part in my lecture 3. So this is true specific gravity. True specific gravity generally deals with the soil solid. Remember this thing. True specific gravity generally deals with soil solid. Now write down a note here. A note. There will be two notes, 1 and 2. With increase in organic content, in soil, its specific gravity reduces. With increase in organic content in soil, its specific gravity reduces. Next note. With increase in mineral content like iron, specific gravity of soil increases. Okay, so let us come to the first note. With increase in the organic content, specific gravity reduces. How? Because organic content can decompose and it will react with the solid part and it may destroy or decompose the solid part of the soil. And when it will destroy or decompose the solid part, generally the weight of the solid part will be reduced. As organic content react with the solid part, unit weight of solid equals to weight of solid by volume of solid. As organic content react with the solid part, this Ws will be reduced. Okay, react with the solid part and it will decompose the solid part and then the Ws will be reduced. That's why when we mixed up some organic content in the soil solid, the specific gravity reduces. But let us come to note number 2. when we mixed up some mineral content, it will, but when we mixed up some mineral content and mineral content does not react with the solid part, that will just add some weight in the solid, remaining solid plus weight of the mineral content by volume S. That means the gamma S will increase. That's why when we add up some mineral content, specific gravity increases. Now come to point second specific gravity, that is mass specific gravity, and the definition will be same. Okay, the density of a soil with respect to density of some standard fluid, but mass specific gravity deals with the whole soil, not only solid part. So mass specific gravity is equal to density of soil by density of water. Multiply it by G, it will be gamma soil by gamma W. Soil means bulk unit weight. Of bulk means the whole soil by unit weight of water. Okay, and now so this is, there are two specific gravity, true specific gravity and mass specific gravity. True specific gravity deals with the soil solid and mass specific gravity deals with the total soil. That's why this is gamma bulk by gamma W. And now generally mass specific gravity is less than true specific gravity. Why? Because Gm deals with the total unit weight and Gs deals with the unit weight of soil solid. And now this is W by V and this is Ws by Vs, and V is very greater than Vs because total volume of solid plus volume of air plus volume of water, total volume, but volume of solid means only this part. That's why gamma is less than gamma S, and as true specific gravity directly proportional to gamma, and that's why Gm less than Gs. Now write a note here. In India, specific gravity is defined at 27 degrees Celsius. In India, specific gravity defines at 27 degrees Celsius, and if it is required at any other temperature, then corresponding change in unit weight should be take place, and the equation is Gt equals to G 27 degree into gamma W by 27 degrees Celsius by gamma W into T. This is note number 1. And now note number 2. If nothing is given in the problem, then given specific gravity will be treated as true specific gravity. In your exams, the what type of specific gravity they may not mention, but in that case you have to assume the specific gravity is as true specific gravity. Now relative density. And what is this? Relative density actually the combination of soil densities at its different stage. That means a soil may be in loosest form, it may be in densest form. A relative density correlate the densities of soil mechanics. Now what is relative density? The relative density is a parameter which represents the compactness of cohesionless soil, and a new term has arrived, that is cohesionless. I will come in detail about this term cohesion, cohesionless, coarse grained, fine grained in my next lecture. But today just note that cohesion or cohesionless means in soil mechanics, if there is a attraction property between the soil solids, that is called the cohesion. If there is no attraction, that is called cohesionless. Just know this as a cohesion, cohesionless, and I will come in detail in my next lecture. Okay, and it is an index which tells the degree of packing between the loosest and densest state of coarse grained soil. That means relative density only deals with the cohesionless soil. As now, what is the formula? ID relative density is equal to Emax minus E by Emax minus Emin. Emax means void ratio when soil is in loosest form, and E mean void ratio when soil is in densest form, and E natural void ratio. This is a relation. As relative density depends upon the void ratio of soil, that's why it deals with only cohesionless soils or coarse grained soil where size of the voids are bigger. And now, by this term relative density, we can classify the soil. Note down here, if 0 to 15%, then very loose. If 15 to 35%, then loose. Very loose, loose. If 35 to 65%, then medium loose. If 65 to 85%, then dense. If 85 to 100, very dense soil. We can classify a soil mechanics. If we can classify a soil by the term relative density, what will be its value? We can then classify the soil. Okay. So write the whole note here. Relative density. Okay. Now relative compactness. Okay. It generally deals with both type of soil, cohesive and cohesionless soil. And what is formula? Relative compactness equals to density. It is defined as the ratio of dry unit of soil to the maximum possible dry unit weight of that particular soil. And we have already know that what is dry unit weight. Go to my lecture 2. So this is the definition of relative compactness. Ratio of dry unit of soil to the maximum possible dry unit weight of that particular soil. Okay, now write a note here. Note number 1. There is a relation between the relative compactness and relative density of soil. RC. Percentage equals to 80 plus 0.2 into ID. Very important formula for competitive exam purpose. And this is the interrelationships between the index properties of soil. This is point number 1, eta is equal to E by 1 plus E, and this is point number 2, the second formula is ES equals to W into G. Just go through the process, you will understand how this has came. Okay, ES is equal to W into G, E means void ratio, S means degree of saturation, W water content, and G specific gravity. All of this term has covered in my previous lectures. And now point 3, unit weight, bulk unit weight. The formula is gamma W into G plus ES by 1 plus E, G specific gravity, E void ratio, S degree of saturation, and E void ratio, gamma W unit weight of water. Just go through the process, you will understand how this has came. If soil is dry, S equals to 0, then the formula will be gamma dry is equal to G gamma W by 1 plus E. If soil is saturated, S equals to 1, then the formula will be this. And for submerged unit weight, gamma submerged is equal to gamma sat minus gamma W. Just subtract the gamma W from this term and this formula will came. Okay. And now the last formula, gamma ball is equal to W by V. That means total weight W of solid, weight of solid by weight of water by total volume. And then W divided by Ws, then multiply it, same thing. Then WW by Ws is equal to water content, and then Ws by V, weight of solid by total volume. That means dry unit weight gamma D. So gamma D is equal to gamma ball by 1 plus W. Now the whole interrelationships between the index properties of soil finished, and now solve the workbook 2, which is given. Workbook 2 solve. First solve workbook 1, which is given in lecture number 2, and now solve workbook 2. Thank you.